Well, hi, good morning. Thanks so much for joining me in my shop here. It's July 16th today, and I hope to start making some actual improvements to this radio. But before doing that, I think I'm going to check its ability to receive shortwave. I changed two tubes on the radio. Prior to that, when I tested the radio for how well it was operating, it was pretty clear the shortwave bands were very, very weak. The AM seemed to be working. At least I hope I'm not confused by all the radios I've been working on. I think that's how this one goes. So having changed two tubes, I think it'd be a good idea just to take another look at how well the set is working. And I have this string here, which, you know, this string does not appear to be broken. Maybe I will try to fit the string back on. It seems to all be here, oddly enough. The other thing I can do is I can double check and make sure these wave bands are, the lights match the bands. I don't know, did I do that last time? So I'm going to flip the radio down here. And I'm going to check that power cord and see. Okay, looks good. Volume down, band on broadcast. Antenna is still connected. Very good. Plugged in, yep, here we go. See, this light came on here. You can see the dim bulbs coming on over there. Just give it a moment. Good enough. Okay, very good. Now, in order to do this band by band thing and to get some kind of quantitative notion as to how sensitive each of the bands are, we're going to need that guy operating. Actually, I'm going to take off the antenna from the back of the radio here. So do away with that. We're going to rely on this signal here. It's all that crackling. Okay. Now my counter has gone a little crazy up there with all the 8s, but it'll come around in a moment. Okay, so next band, the light comes on here. Supposedly it's this sort of general shortwave band. The way this radio is set up, it has one large range shortwave band. This goes all the way from 6 to 18 megahertz. Has all the different, or most of the different broadcast bands within it. And then they've selected out certain ones, like right around 9 here, and stretched it out into this. And they've done the same thing with 11. They've taken 11, which is about here, and they've stretched it way out, and 15 stretched way out. So the tuning on these 3 bands is very easy. And then you have this overview one. Harder to tune on here because a little bit of movement makes a big difference. Pretty quiet. Oh, speed of the devil. Very, very quiet. Okay, so we don't know where we're tuned here. I had kind of, we'll put it sort of in the middle. Okay, I'm guessing this is about the middle. The middle of this band puts us around 9.5 megahertz. See, my counter is still not counting. Just like magic, the number came up. Something's loose here. Hard time reading the numbers over yonder. It's 15 megahertz right now, and we really want it around 9. Okay, so this is a moderately strong signal coming into the radio. So we'll dial this down to 9. So having replaced 2 tubes, one of 2 things are going to happen. Either the radio is going to come to life on these bands or not. And if it doesn't, then obviously there's some other thing going on, which I think is really where we're at. We've got full volume on the radio now. Okay, so let me tune the radio itself. There it is. Very jumpy. There we go. Very good. Is it definitely this guy? Yes. 9455 is where we happen to be. Put this over here. There's a reason for doing this. 9455. So something like that. Gives me an idea what frequency we're on the rest of the bands. How come so close to the edge? Does that make sense? The capacitor's half open. It should be over here. Let me just swing this guy around just in case we're listening to an image, which I don't think is really possible on this band. Let's just go hunting. Can't go below 9. Let me do this. I'm going to put this right on one edge, or one limit. Closed capacitor. Where are you now? Okay, so now it's probably gone below the range of this. Let's do it. What do we do at the other extreme? Open capacitor. Okay, capacitor is all the way open. We should be up here, somewhere around 9.5. I just don't want to change bands on this signal generator. I'm too lazy. Nothing. Give it some more juice here. 9.6. So 9.6 is about here. So that's not quite right. The capacitor, the way it is, the tuning capacitor, we should be out here. It should be 9.7, not 9.6. We're just going to check for an image again. I don't think it's possible. No. Okay, that's what it is. So just an alignment issue with the radio to get the dial to be accurate. Now what about sensitivity? We changed tubes. Did we get all the sensitivity back? So the radio is cranked up on full volume right now. This is it. There's no more. The signal generator is putting out a signal that should be plenty strong in Is the radio not the cause? Something else in here is something in my shop is rattling away. Don't know. Okay. So with that kind of signal strength, this kind of volume, something definitely is wrong here. And I think we're going to find the same thing on every band. So we'll go to the next band. Oh! Wait a minute. Okay, just totally confused myself. Isn't this where we just were? Oh, parts of my mind have disappeared. Okay, I have recovered parts of my mind. Okay, we're on this band. We're not on this band. Dope. Well, this is way out. This is 11. This is almost 12. And on my signal generator's running at 9.5 right now. Way down here. This is open wide. So we should be up here. Okay, you know, I'm starting to get the feeling that these lights aren't pointing at the right band. Oh, come on. Really? So I'm up here. We should hear something at 18. Maybe, you know what? 9.5 is about half of 18. So I'll bet you this pointer is throwing me off here too. Look it up here. This is where we are actually tuned. I'm sending a signal in at about 9. I'll bet you if I dial this up to 18, it's going to come screaming out of this radio. Let's try this. Turn it down a little bit. 18. Whew, did you hear that? Okay. Boy, am I really booming this up right off the start, but I recovered. Don't know what all this scratchy sound is. Oh, that's interesting. So what that crackling was all this time was this little clip. Better take it back. Okay, what I thought it was this little clip swinging over and touching the cabinet of this meter. We don't know. I don't know. Whatever it is. Seems to be gone. Okay, where are we at now? So we're finding the signal. 18.2. We're dialed in at about, well, 19 is where we're dialed in. More. Well, you know what? Well, it could be 18.2. They're doing something funny with the dial here. So that's good. And signal strength now, what you're hearing is, again, just check this out here. Calibrate. So that's 1,000 microvolts roughly on the antenna. That's a strong signal. The volume is well more than halfway. So I'd say it's a weak radio, seems to be working. Band is correct. Okay, now keeping my head together. Now I'm on this band. So up here we'd be around 9.7, something like that. So I'll dial in 9.7 over here. Turn the volume full. More power. .65, 9.7, so very close. Should be very close. I hear nothing. There it is. It's a very strong signal coming out here. What was that? So something changed, and then there's a little heterodyne in there now. Okay, the volume going up and down. be dirt in all these controls that I haven't cleaned yet. Oh, look at that. That's a guy. Full volume. Okay, back to what we're doing. Very strong. And not doing anything. And it just, wow. That's pretty interesting. I'm just standing here. It's all gone away. Is it this? Is this radio? How did it all go away? Well, that's a little odd. I have to admit, everything's kind of odd here right now. Okay, recap. We're tuned in at 9.652 on the signal generator. It'd be right about here. So it's taking a strong signal. Holy jumper! Holy smoke! Did that ever make me jump? What happened there? I wasn't touching a thing. I'm now sniffing for smoke. Maybe something gave up the ghost just then. Okay, band switch. Let's go back to AM. Okay, AM still there. Shortwave appears to have just gone away. Gone totally away. Okay, full power. Nothing at all. Nothing at all is happening here. Smells like something is burning in here. Oh, jeez. Okay, this kind of stumbled on my camera cord there. Let me just reset my camera. It's actually off. The one you're looking through is actually off. There we go. Stumbled on the cord, yanked the camera, unplugged the cord. Back to where we are. Let's go back to this band and see if it's gone away too. Sure seems to have. 18. Oh. Not at all. Not at all. Okay. So all these observations will help somehow. Somehow at some point. Capacitor's all the way open. 9.7. Let's just put it back down there again. Let's see what. Nothing. It's really quiet. Okay. Big blasting signal. 9.6. Nothing coming out. Volume's all the way up. Nothing. Okay, so what I've done is I've destroyed the 31 meter band sitting here. Let's go to the next one. We're going to guess it's the 11. Because if I do the next one, the light comes on. So by rights, it should be this one. We will tune, well, we'll stay up at the top because I don't know where we are. I should put the string on. I really should get the string on. 11.9 is where we are. Putting out a moderate signal. I mean, we should be hearing hiss, right, with the radio turned up. We should be hearing a lot of hiss. 11, what did I say it was? 11.9. Here we go. and 3, 4, 5, 6. Okay, so there's nobody home. Bands are mixed up. Ooh. So I'm feeling the temperature of the power supply transformer here. It's getting pretty warm. How many watts? Oh, something wrong here. Something is wrong here. We got 102 volts there. It should be. This is what's wrong. It's no big deal. This is a big deal. This is putting out 125 volts. Something is wrong here. Something is wrong. So I don't have the dim bulbs in. So we should be getting the same voltage that this is putting out. Where's the voltage dropping? Something's going wrong here. Something going wrong. Let me just keep one of these lights on so I don't forget the radio's on. Okay, so what I can do is I will shut the radio off and we'll see if this floats up to whatever, 125 or something crazy like that. Here we go. Okay, so it remains the same. But did you catch this meter move? There's something very odd going on here. I don't like this oddness. 117. Now I'm going to turn the radio back on. This is going to stay at 117. It's this meter which is reading the same thing. Oh, that's not the switch. Here's the switch. Here we go. Radio coming on. You see that drop? 112 here. Well, my thinking is the output of this is extremely stable, so it shouldn't change. Somewhere there's voltage dropping. What's really got me nervous here this morning is I can smell something, and you know, for all I know, it's my socks. I don't know what I'm smelling, but. Could it be a bad switch in my panel here? Okay, so I can't imagine that's the problem. I don't know. What's going on there? What's happening? You gotta enjoy it when you don't know what's happening. Literally, you have to force yourself to enjoy these moments. Ignore it all and just carry on. Ignore it all and carry on. Let's do that. So right now I've got this top band switched on. 15 megahertz, 15.37 or something like that. Let's see if that's really there. Signal generator is a moderate signal. 15.3. I think we're going to find out that all these shortwave bands are doing the same thing. Okay, nothing at all. Okay, super strong signal. Volume. Volume's right up. It's just become so quiet. There's no crackling at all. What about the band switch noise? Oh, there isn't even band switch noise up here. Oh! Oh! It seemed to work there for a moment. Dirty band switch. Is that all this is? I don't think so. It's making noise now. Was it not making noise before? Right, this last switch position should be turning on a light here that says phonograph. You probably can't read it, but in there it says phonograph. When I get to here, it should turn the light on here, which is probably just burned out. Phonograph. Dirty switch, eh? Okay, I think that's enough fiddling around for now. I have to stop for a bit, think about this, and decide on my next step. And, did something real happen there just a minute ago, or was that all just ghosts and goblins in my shop? I think it's ghosts and goblins. Okay, after consulting with my coffee cup, the coffee cup says clean up all those things, clean up the controls, clean up the switch, and maybe get the string back on before doing anything else. So that's what I'm going to do. So let's just pull the plug on it here. I've got a pretty warm transformer. All these transformers are bound to get a little warm. How warm is too warm is always tricky to judge. Certainly, if a part in your radio, aside from the tubes, like a transformer is so hot, you put your hand on it and you have to go like that. That's too hot. That's definitely too hot. A little warm, again, nice glowing warm. That's okay. In the middle. So there's a good chance these old capacitors are causing a number of situations in which there's more current flowing than there should be. And that may be putting a little extra load on the transformer, which is down here. First we will clean the controls here. So I'm just going to use a special fluid. And the idea is to spray it into each of these adjustments. Now, to spray it in, it's got to go in through a hole. The gaps are usually right behind these terminals here. Not much of a gap on this one. Looks like I can't easily spray it in here. Sometimes there are literally holes in the shell or the can of the control, but I don't see any. Okay, I'll skip this one. Do this one. Unfortunately, the radio has to be turned around the other way. I'm going to spray it in here, and it's going to want to use gravity. I'm going to want it to use gravity to get into the rest of it. So let's leave this one aside for now. Under the volume control, the terminals are sticking up, and I should be able to easily spray this right in there. These usually feel very smooth. This one feels kind of bumpy. You can almost imagine inside a little piece that's sliding around, it's sliding over top of gooky, greasy oil or something. But this was working okay. So it's possible I'm feeling it just in here. That's a shaft and a sleeve. They usually bind up a little bit, so I'm going to put a little WD-40 right in here. There we go, smooth as can be now. So that's what that was. Very good. as we'll do these others. Just a little wee bit. Okay, 2 left to do inside, 1 anyway. Now about the switch. So here's the big wafer switch here. It's called a wafer switch because it has wafers. 1, 2, 3, 4 wafers in it. So the best way to clean this guy is literally to hose him down. Now the wafer has 2 sides. Sometimes all the business is on one side, sometimes it's on both sides of these. So you have to look to see. With these, I find when you start, the snap is kind of a thump, 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 thump. And as you clean them up, it goes from a thump, thump, thump to a snap, snap, snap as you get rid of the oils and the greases and stuff that are in there. That's what I find. It seems like just gas is coming out of there, and there's no liquid. Okay, so we want to get this guy, and we want to try to get that one. Flip the radio right around. Is there anything else before I do that? Any other switches or anything that should be sprayed? Well, we have a whole whack of push button switches up here we're going to have to take a look at. Maybe that's a little premature to do something with those right now. We'll leave those right towards the end of the whole process. I think the answer is no. It's good to go. Flip it over. Best way to flip it over is this way. And it's going to be unstable because the transformer is going to be up on top. Okay, here we go. Very unstable. Okay, now. Holding it here. Okay, the control is here now. Oops, wrong one. We can look at the other control up here, looking for any kind of gap or hole. Turn up my lights here. I have a new light in my shop I put in a couple weeks ago, and it is mighty bright. It's like sunshine in here right now. And what are you doing? We're looking here. Because one of these appears to have a gap in it. Well, let's just spray it in there. Right past the terminal here. Okay. Don't know if that really went in. And now it's time for me to... That's an alarm going off. Okay, let me set this down. Let's go and attend to that. Okay, a couple more things to clean and lubricate is the tuning capacitor here. Now, looking at the capacitor, two of these stages, two of these collections of plates are for tuning the front part of the radio. And the last one is for adjusting that internal transmitter, the local oscillator that's running in a radio like this. If you look carefully at the plates here, you can see that this outer plate is bent inwards a little bit. And I'm going to bend it out, just my eye, so it matches the rest of them. This one's pushed in a little bit too, right here. I'm going to pull that one out. Now, there's an alignment issue here with these plates. These plates have splits on the side of them. Can you see there's like a split cut into it? Well, that's so you can do what I'm doing. You can bend these outside plates a little bit and make a refinement on how their capacitive value varies as you adjust them. That's very much a factory operation. The reason I'm bringing this up is because when I look at this inside one, which is hard to see because of the get this out of here. Actually, stick it there. Stay there. You can see that the plates here are bent out quite a bit. So bending in can happen by accident. Bending out, not so much. If they're bent out, it's probably a technician that did that in the factory as an adjustment. And I think you would need the right bench setup to really pull off an adjustment of these. So I tend to not fool with these outside plates. I really do believe you would need a lot of... You need the right bench setup just specifically for that. So here we've got a gear, we've got some gearing happening here, we've got a shaft going through a sleeve, and most importantly, and this is kind of counterintuitive, the plates that move, these rotating plates, sets of plates, are grounded. Usually you're straight to the chassis. And the insulated side of things are the stators, the plates that don't move, the plates that are down. It's a little hard to see, but you can see the rest of them down there that are meshing. Oh, look how bent out. Look how bent out this one is. So we don't want to fiddle with that. But I did bend ones out that seemed to be bent in too far. This one, see this little corner here, just... If these plates touch, if these rotating plates touch the other plates, the radio will go quiet. In the process, because it's going to be kind of a brushing contact, you're going to hear lots of coming out of the radio when you do this, with the sound coming and going. I don't think we quite saw that. Now sometimes you can actually hear the contacts. It's a little hard to see them because they've put these capacitors right where you need to look. Well, you can see from up here. So I don't think there's any shorts in there. There might have been where this plate was bent over. But I don't remember hearing a whole bunch of oh, there's my cap. I don't want to go out. So we're just going to put a little WD-40 here. Just a little bit here. Now you could use a more conventional kind of oil if you didn't want to use WD-40. Now we're going to knock some dust out from down inside. Let's see if my cat will tolerate. In a few minutes. He's going to be at the top of the stairs here yelling at me. There he is. He has this like a sad voice. Let me go out. So So I mentioned these rotating plates are grounded. Well, how do you do that? How do you have something moving and it's at the same time electrically attached to the frame or the chassis here? Two ways. One is you put in a bond wire, and some of the older radios actually have they'll have a braided piece of wire that makes a permanent connection even though these things are rotating. But more commonly, there are contact springs contacting usually the shaft way down here, trying to ensure and maintain a ground. And you can see them here. I'm going to have to switch to the other camera. So I'm going to stop for a minute and go save my cat. Okay, my cat's outside. It's just a beautiful, beautiful day out there. Oh yeah, that's right. I was going to switch cameras, and then we were going to take a look at how they ground this rotating piece. So let me point to what it is. It's not obvious. Right here. This is a copper piece. This copper piece right here. It's connected to this. This is part of the frame, and then this is part of what rotates. Let me turn it. And that's the contact between what looks like a copper piece. There's usually one. These things usually more than one. So here we are, just a little further over, and there's another one. These lose their contact. Look at how corroded it is down in there. These can lose their contact. And there's often one right on the end, too. Don't really see it here. When these things, and maybe up at the front, when these lose contact, when you tune the radio, you get, and it may come and go. It may just go. It may never ever work properly. So how do you deal with that? So we're going to use the more expensive contact cleaner now. For years and years and years I relied on nothing more than WD-40. But then I finally went out and I bought this. This is expensive stuff here. Deoxit. Yeah, I don't know. Can it really? Is it really much different than WD-40? Okay, so I'm going to spray right on those contact zones. Is this going to bring the radio back to life on the shortwave band? It's not very likely. Okay, so we also have under here will be a ball bearing, almost certainly a ball bearing system here. I'm going to try to. That's WD-40 I'm dousing it with. And then there's a pivot on the far end, usually an adjustable one. There's usually a screw here. You can tighten up and loosen loosen it. And that's also adding to the grounding. Okay, well I don't think there's much more we can do about that. The string will be for tomorrow. I'm not going to do the string today. So now an observation that's worth making. You can see that the capacitor is mounted. These are rubber grommets here. It's really hard to recognize them as rubber. Let me get a close-up of them because there's something about them that needs to be looked at. So you see how they've cracked all around the outer edges from the stress of being squeezed by that screw for years and years and years. Well, that's interesting. Look at the metal. Is that metal below it? Or that's more grommet? That's more grommet. All cracked up. The thing about this now is you have to say to yourself, wait a minute, that frame is not grounded solidly through these screws. It doesn't appear to be. couple of reasons for putting these up on a grommet. Up on grommets, some of them electronic, some of them simply mechanical. Sometimes it just gives a little bit of movement in this because the shaft is going straight out and the pointer's on the end of it and other stuff. Not in this radio, but in some radios. So a little play in here is helpful. It doesn't feel like there's any play in this one. Of course, these things are probably pretty hard now. Well, they still feel kind of soft. Another reason, one I just learned. Couldn't have even thought of this. If you turn a radio up loud enough, a speaker will produce enough sound to cause parts of the radio to vibrate inside here, like maybe this can will start vibrating. Well, one of the things that can vibrate are these plates, and this whole tuning thing can vibrate. And if the sound of the speaker is, especially if the speaker is mounted on the chassis, now this one isn't, this is mounted way underneath, so not the same issue, but in a lot of radios the speaker's mounted on the chassis, shakes the chassis. You want the shake to be weakened by having rubber grommets in here, or you'll shake this. That can cause a feedback, because if you shake this a little wee bit, it will cause variations in the way the radio's tuning. Those variations will come out the speaker, come right around and back in again. You got feedback. So I've never encountered a radio with feedback into the capacitor, but that's one of the reasons for that. I didn't know that. Now, is there a really solid ground on here? And I think there is. I think you can see it right here. So regardless of the rubber grommets, the frame is attached solidly to the chassis. Now that's an important observation, particularly in a smaller radio without a power transformer. It doesn't have one of these. It's a 5-tube, so-called all-American 5. There's Canadian radios built that way too. They've got a danger with the voltage on the chassis, and there's a danger with this being isolated from the chassis and all kinds of stuff going on. Not the case with this radio. These big radios with the big transformer here are relatively safe when it comes to chassis voltages and the like. Okay, so that's the story here. Grounded solidly. Now what about these push buttons? Now I think some radios, the push buttons are actually little independent tuners that maybe are sliding something in a coil or doing something like that. Others actually turn the tuning capacitor. Let's see what happens when I push this button here. If I can push it. There. So these buttons mechanically push on the tuner. Now I'm going to explain this as best I can. You see this plate right here? And there's another one down lower. Down there. I can't see it right now. Maybe you can see if I do this. There it is. See those two plates? Now if I took my fingers and held them very stiffly and pushed on those two plates, maybe I pull one finger back, then in this example my lower finger would push the lower plate. It would cause the capacitor to move until both plates touch my finger. Both plates touch my finger, it will stop. And if I put it this way and push it with my fingers like that, and back to the same spot. And if I push it this way and then shove my fingers in there with my fingers held the same way, back to the same spot. Look, there's fingers. There's fingers on those there controls. There's an upper finger right here, and then a lower finger down below. You can see better on this one. Upper finger and lower finger. When you turn the adjusting screw, you're taking these two fingers and you're kind of doing this to them. Probably just moving one of them. Probably just moving one finger forward or back. And when you plunge the button, the fingers come in, hit those two plates, and rotate this into a very certain place. Pretty simple stuff, eh? Pretty simple stuff. And then there's springs that retract these back so they don't, yeah, you can see the springs there, so they don't stay forward. A lot of these have I said you turn the screw and you turn the fingers. Not quite true. What's happening here is you turn the screw to loosen off the mechanism. Now the fingers will be floppy. The two finger plate there will rotate freely. Once you unlock the string, unlock the screw, you then tune the radio where you want it. That sets those two contact plates in a certain position. There we are, tuned in. Beautiful. Love that. Then with the button unlocked, you push it forward. That causes the finger plate to rotate to match these. It doesn't turn this, it just matches it. You then get out your screwdriver, lock this down. Now the fingers are locked, so every time you push it in, it'll return the tuner to this position. That's what's going on. Now you can see they can have as many buttons as they want, because it's the same thing over and over and over. There's no coils and wires and none of that kind of stuff involved with these particular ones. Notice the buttons are mounted right on the chassis. In other circumstances, these buttons are mounted off the chassis. They can take a different place in the cabinet, maybe a more attractive location. But in that case, almost certainly there's no mechanical linkage back like this. Instead, pushing these buttons is actually tuning a coil. You're moving a slug in a coil, a whole different system. Very good. Nothing in here to oil up now. I think all we got to do is just run this radio and see if any of that made any difference at all. So I think it'd be helpful if we had the speaker plugged in again. My air conditioner coming on probably. Yeah, it's warm enough for air conditioning, that's for sure. Today's going to be, the high today will be 28 degrees, which is warm for here. I think the humidity is going to be moderate, so it won't be too muggy. And I'm almost sorry to say the fantastic weather we're having here, because I know so many people in the world are suffering from terrible weather of various sorts. Not here though. Okay, we're safe to plug in. Go on the AM band to start. Volume down, switches on. Antenna not connected. Need an antenna here. Antenna but no ground connected. Sometimes when I wait for these radios to warm up, I start sweating. Good volume. Everything normal there. Yep. Sometimes it's hard to tell if what you're hearing is scratchiness from something going on here or whether it's just tuning through noises. That's tuning through noises, I'm pretty sure. Literally no quiet spot left on the shortwave, on the broadcast band. Noises everywhere. Okay, next band. No volume. No action. Nothing. We got nothing. So it's actually gone downhill, hasn't it? Anybody got any sound? Nobody. So this should be actually roaring with a hiss right now as I flip through these. Should sound like the broadcast band. Should sound like this all the way through. Okay, definitely something not right in here. So my options here with a radio, with the AM working, and I'm fortunate. That proves a lot of the circuits. The shortwave, in trouble on all bands, suggests the problem has to lie in an area that's common only to those bands and not to the broadcast band. That points to the front end of the radio, close to the antenna. There's something happening in there. Now there's a whole pile of bad capacitors in there. I could just start changing them out and see what happens, or I can be a little more thoughtful and try to target one or two of them as the culprits. I think that's what I'd like to do, because I find that fun. I find the puzzly part of this work a lot of fun. So tomorrow string goes on. We'll get that sorted out and then we'll be thinking more about which capacitors to do first, and can we is there actually, maybe there isn't just one thing wrong. It could be, you know, a whole bunch of weak parts combined are drawing it down. My guess, one component in particular is affecting the shortwave. That's my guess. Okay, well, thanks a lot for watching. I'm going to go enjoy my day. You enjoy yours. And tomorrow we will beat this radio up some more. See ya.